So as usual, let's continue our studies of Linux. Now, in this particular release, we'll look at SUSE, which we have not looked at for a while because the releases have been few and far between, so quite a bit of time has elapsed. Now, typically, before we get rolling or underway, we have already set up or configured at least a desktop of the distribution that we're using. But in this case, we have yet to do so. So it affords us the opportunity to provision a desktop. So let's go ahead and provision a SUSE desktop. We can use the server software and just ensure that the desktop's installed. So let's go ahead and we're going to use VMware Fusion on our Mac OS X system, which is our front end for recording. We already have the server DVD ISO image available that you can download obviously from the SUSE website and just check some of the settings, make sure everything looks okay. Let's say we call this one Linux CBT SUSE Desk 1, and then we'll modify the specs to fit what we expect. So let's take a look at processor memory. Now typically we like to give at least a gig, so let's ensure that that's in place and go back. In terms of networking, we normally bridge as opposed to NAT so that it picks up an address from the DHCP server on the network as opposed to hiding behind the routable address of the routed interface on our Mac. In other words, a default interface. So let it pick up its own address from the DHCP server where possible. In terms of storage, let's take a look. Well, 20 gigs more than suffices. Anywhere 5 gigs and above will allow you to run pretty much any distribution of Linux. So 20 gigs should more than suffice. And as is always the case, we can bring storage online as needed, and that is not a problem. So 20 gigs will get us as far as we need to go. Sound is usually not an issue for us. We're not generating any sound using any sound software, so that can be ignored. We're largely concerned with processor, memory, network adapter, storage. Take a look at display. This is just some defaults for acceleration, so it gets, or presents at least to the operating system, a pretty decent graphics card so it can generate the graphics that are necessary. So this looks good. Now in terms of booting, well, the ISO image should already be tied. Let's take a look at CD SATA. So this is the ISO image and it's set to connect when the system boots. And the default for the SUSE ISO image is that even if the operating system's installed, it'll boot from, well, VMware will cause the ISO image to boot, but the SUSE menu will provide you with the option to boot from the hard disk in the event that the disk has an operating system already. So you need not worry about having to flip this switch or disable the ISO image boot post-installation. So if that looks good, let's fire it up and get underway with the installation. Again, this is really straightforward. So this is our VMware instance. This is the SUSE startup screen with the multiple languages, and if it's already installed, then obviously you can just select that. Now, we'll proceed with an installation, and as we know, there are various options for resolution, so on and so forth. You can set the video mode that fits your configuration, and that'll allow you, for example, or at least it'll allow us to achieve a particular resolution. So let's say we go with 1366 by 768. The source is the ISO image. We're not passing in any kernel drivers or any changes, so we'll just go with the defaults. Like with other distros, such as Red Hat CentOS, you can check the memory as well as the ISO image itself or the CD, DVD. However you've obtained the operating system, you can confirm it to ensure that you'll be able to succeed with the installation. But nowadays, that's usually not a problem. If you've checked the ISO image that you've downloaded, then that should not be a problem. The option here to upgrade is available as well. As we know with the SUSE distribution, it's really well developed, so with respect to upgrades, etc., that's usually taken care of and usually not, or usually less of an issue compared to, say, other distributions. So let's proceed with the installation. So of course, all the distros nowadays are using the 3X kernel series, and that should come as no surprise. Some slight differences, perhaps one major difference with this release is that it's using the BTR-FS or B-tree file system as opposed to ext4 or riser-FS. Traditionally, SUSE uses riser, but now it's using BTR-FS as the default. ext4 is still supported. XFS is also supported, as we saw with the Red Hat release, which now defaults to XFS. Again, regardless or irrespective of the Linux distribution that you're using or du jour, the kernel supports myriad file systems, drivers, functionality, etc. So you can always figure out a way to compile your kernel to support your desired configuration, which again is what makes Linux so flexible and so usable. So as you can see here, this has popped up to the desired resolution, which limits our shifts or switches in between small resolution, high resolution, low resolution, so on and so forth. So this should be detecting hardware. We should be able to move forward shortly. Default English for us. Although we're still in Japan, so I guess we could use some Nihongo. And let this go ahead and initialize the system. Pick up on the hardware. This is, of course, if you want to register the instance to get support. We'll skip that. That's not necessary for our intents and purposes, usually. And this is the option you may have seen with prior releases of SUSE to obtain sources from, or additional packages from other sources such as internet-based, local, so on and so forth. We'll just go with the defaults, which gives us more than enough. Now, with the B-tree file system, it creates sub-volumes off of the root file system. So the root file system is BTRFS, and BTRFS has inherent snapshot capabilities, which rides upon this notion of sub-volumes. So don't be alarmed if you're unfamiliar with BTRFS or other file systems such as ZFS, which creates or uses the notion or the idea of sub-volumes, effectively turning key directories such as opt, home, so on and so forth into subdirectories or sub-volumes of the main volume. The real idea or the essence of this facility is to support snapshots. BTRFS supports snapshots, so you can take snapshots of your file system, which will allow you, in the event of issues, let's say surrounding updates, broken packages, implementations, etc., to roll back to various snapshots or timed instances. So think of BTRFS in terms of ZFS, if you're familiar with Sun and ZFS, with the ability to, on the fly, generate file systems matched to pretty much any directory. And with that comes the flexibility to take snapshots and to treat directories, plain old directories, that would be historically beneath, let's say, the root file system or its own file system, but not have the capabilities provided by file systems such as ZFS, BTRFS, so on, namely snapshots. So these subvolumes support it. Of course, you can make changes. And BTRFS is fully LVM aware, so that can be used as well. But we'll just go with the defaults. This will just create a root file system, and beneath it, and as you can see here, it's doing so, or will do so under dev SDA2, whereas dev SDA1 will be the swap. And then within dev SDA2, subvolumes will cover everything from the boot mount point to home, opt, var, so on and so forth. So let's just go with the defaults. And of course, this gives us the ability to locate ourselves somewhere in the world. So let's see where we are in the world. We like etc GMT because this gives us a generic time set. And of course, we're here 9 hours behind GMT. However, GMT gives us a common reference, so we stick to GMT wherever possible. Now let's set up the default users. This is stock on Linux systems where you define the first user. And of course, this user's password can be one and the same as the root user's password. And this user should receive system mail, but should not log in automatically. This interface should be familiar to you from prior releases. Again, this is the YAST installer, which presents the information surrounding the system, the software that will be installed, various options in a very clean and logical fashion. So, software-wise, SUSE Enterprise 12, documentation, AppArmor, so on and so forth. It will provide backwards support for 32-bit, although this is 64-bit base code. This will require 2.5 gigs if you need to make changes to the software. Click on Software, have a look at the different categories. Maybe you need, let's say, compilation tools, etc. Of course, everything can be modified later on using YAS while the system's up and running. Of course, because the kernel supports virtualization, the two common kernel forms are Zen and KVM, KVM being the more popular of the two. But of course, both are supported because it's inherent to the kernel. So although we're installing this as a desktop, it can certainly function as a host, as a virtualized host, if you will. Let's just add our compiler tools. We like to have our tools available in the event that we come across interesting software that should be used. So let's click on OK. Let's see what's happening here. So that's the software section. We need no additional software. Booting, it'll boot using grub2 from dev-sda2 from the boot file system or the boot subvolume beneath the root file system. And this option. Now, some of these options are presented in a somewhat confusing fashion. For example, do not install the bootloader into the master boot record. And it reads install, whereas this reads install boot code into the root partition. Do not install. What this effectively means is that it'll place the boot code into the root partition, because with BTRFS, the bootable area is now a subvolume. /boot is simply a subvolume of the root file system. So the boot code has to be placed by default into the root partition. However, that can be altered. And then, of course, the grub environment will be updated to reflect. So you can place the bootable code into the master boot record. But then, of course, the installer will write it such that it knows where to find it, it being grub, that is. So the default is to place it within the root partition, within the boot subvolume. In terms of firewall, SSH, well, this enables it by default. So if you want, you can disable it. SSH port is blocked. If you want to be able to connect to it, open it. So we'll just go ahead and open it. That'll make a change. That way we can connect in from other systems as we test SSH, as we tend to do. And whether or not SSH will be enabled, well, it's enabled, but to disable it, click on disable. So the options are just presented in a somewhat confusing fashion. It seems as if it's the opposite in terms of enabling, disabling. So just read it carefully and pick your choices. So SSH service will be enabled means it will be enabled. And if you want it to be disabled, click on disable. Firewall will be enabled. Click disable to disable it. Kernel dump, that's disabled by default. Can be enabled if necessary. Perhaps we'll do so on one of the servers. And system and hardware settings. Let's see. This is going to tell us what hardware it's found. So let's just go through. Of course, this is all virtualized, but nonetheless, the key components should be represented. So let's see what it's picked up on. And this does a full check. Let's see what it's found. So detecting hardware. So this is found, well, obviously a BIOS and VMware SATA disk, emulated floppy, Pro 1000 Ethernet, and as you can see, VMware shows up all over the place, etc. Kernel settings. Well, if there are any settings that need to be passed into the kernel, they can be, but these defaults have no impact on our configuration. And of course, as is the case with SUSE, another useful feature which we find with Red Hat, which of course means CentOS as well, is that a full description of the installation is written somewhere. In this case, it defaults to root auto install XML, which can be used to reinstall the system on other instances rather quickly. In today's hyper-virtualized world, it's very easy for us to snapshot our images or create images and replicate them. However, you may also use the facilities provided by the operating system, such as AutoYAS in the case of SUSE Enterprise Linux, or Kickstart in the case of Red Hat, CentOS, etc. So this is a full descriptor using XML, of course, written in XML form, which allows us to easily replicate the options that were selected for this particular instance. And notice, since we've added the compiler tools, that the footprint has extended from 2.5 to 3.2 gigabytes. So no problem. Still under 5 gigs. Let's go ahead and install this. And that's the final stage. That's your final option, if you will, to back out of causing any somewhat irreparable damage to the file system or to the disk area that you're going to write to. It's somewhat irreparable because there's still ways to recover so long as you don't overwrite the areas that are of interest that you'd like to recover. So this is pulling everything from the ISO, as is the case across all our installs over the years. You still have the consoles available that you can look into to see what the installer is doing, what packages are being copied, any connections that are being made, and so on. So this tells us a little bit about the capabilities, so the ability to snapshot the file system, rollback in the event of issues, and so on. Again, that's more ZFS-like capabilities that's brought to us via BTRFS or BTreeFS. So, new tangent for SUSE. For years, we've worked largely with RiserFS, which has proved to be quite flexible in terms of being able to treat the file system in ways that are necessary for systems that should be somewhat highly available, but nonetheless, BTRFS gives us new capabilities, gives us enterprise capabilities, snapshot, virtualization type capabilities, all built in or inbuilt. While it installs, you get some sort of round down as you or running log, as we've seen over the years. The interface, of course, is slicker, but it's still presented in the same ways we've seen over the years, 9, 10, 11, and now 12. And these are the RPMs. Now again, SUSE is still an RPM-based distribution. So it is one of the major RPM distributions of Linux. And here are the release notes, which gives us some details about what we can expect from this release, any changes from the prior version, so on and so forth. Let's see what this is up to. This is roughly a third of the way. Give it a little more time. And what we'll probably do is elapse it a bit so we don't watch the grass grow, if you will, and maybe re-emerge towards the end of the process, although we're at close to 50%. So let's elapse for now and chime back in. So let's chime back in. This is wrapping up. Let's take a look at our various consoles, as we've mentioned, that you can expect to find. So here's F1. This is the first screen that we saw post boot, which launched YAS. 2 gives us a console with root access. 3 shows us a running log. Another log on 4. Another console, TTY5, root access, 6. And then 7 is the GUI. So, as is the case with a running system, you can expect to have consoles with which you can interact. But over the years, we've looked at different means with which we can interact across SUSE installs. So it's the same. So we'll just wait for this to wrap up, and then get our desktop set up, take some notes, and then perhaps move on with installation of the server. Now, of course, we're using the server package, but it's all one and the same. In terms of the way the interface looks, etc., it doesn't matter. By default, we'd, of course, deploy servers, sans, desktops, or GUI environments, but we can use the same code base for any application, so it's a non-issue. So let's see where we are here. This actually is done with the packages, so it should be writing to the master boot record momentarily, or in this case, a root file system subvolume boot, which is the equivalent of writing to the MBR in traditional installations with traditional file systems such as ext4, etc., XFS. And again, Grub can boot Linux or any operating system for that matter on any disk. So it doesn't matter where it's actually installed. So long as there's an appropriate driver for Grub to be able to read the location, in this case BRTFS, then it's not a problem. So there's the AutoYAS XML, which, as we indicated, is in the root directory, and that can be used to provision other nodes. But again, we have virtualization tools and we rely upon them heavily, so we can clone these systems rather quickly. And all without having to use the facilities provided by the operating system. And this is just finalizing here. There's the boot manager and the configuration, which is written to load BRTFS or BTRFS support and provide access to the root file system and subsequently the subvolumes, namely /boot. And this should be wrapping up momentarily. We'll just give it a little more time. And again, this will become our desktop. And now finally this is done. And here you can see it's no longer booting from the ISO. Of course, we have options here to make changes to the kernel. This is recovery kernel. This is the default kernel. Now we'll detect all the hardware and then propel into our login area. There's the login. Now the login obviously is not at the same HD resolution that we specified during installation. They're separate, obviously. Once we're in the desktop, it'll still be this 4x3 perspective, so that'll need to be changed. Let's go to the display here. And this is our sweet spot. So now we have our desktop. Terminal's always shortcut into the right button submenu or the quick menu. Let's get this instance going. So now everything looks like the standard that we find across our Linux CBT releases. And that is plain shell, gedit, and we can start documenting our stuff. So what have we done thus far? Let's Control-Shift-T, host name. I notice this host name needs to be changed. Of course, it's using a generically derived name, but DFH shows us the new layout of our storage. As you can see, it looks more like ZFS if you're familiar with ZFS. There's a snapshots entry, but each of these mount points are treated as separate. They all hinge obviously off of the root file system. That's why they all read 19 gigs. Again, this is just like ZFS in that regard. And then each is provisioned storage and can be treated as a distinct file system, which includes, of course, inherent security benefits, including but not limited to the lack of or the inability to down the system by crashing a particular file system, as it isn't able to overrun the entire space. So for example, in the traditional model, var is under root unless you specify otherwise, and if you overrun var with log data entry, then you overrun root, then you could potentially cause a kernel panic or otherwise and deny access to the system. So Linux CBT SLES12 edition, and our first task, install desktop. And we did so using the server code. So use server base and enable GNOME. Plus we added, of course, the compiler tools, so plus compiler tools. And this gives us a proper setting. Now obviously we're using DHCP here because we didn't specify any IP settings. We could have. We'll do so for the servers. Let's go to Documents. Make this Linux CBT SLES12 edition notes. That should be documented there. So this is up and running. We gave it 20 gigs, a gig of memory, and now we're up. In terms of making changes, well, one of the slick things about SUSE, one tool seems to do it all, and that's YAST. So any changes, just modify from YAST. You can run YAST from the shell, or you can navigate into applications and find it under System Tools. This should be familiar to you if you've been following along the various Linux CBT SLES editions over the years. And of course, it's presented in a different way, but nonetheless, the objects that are modifiable remain the same. So anything to do with networking, for example, modify the network settings, and this will give us the details. Well, it'll read the current configuration and allow us to make changes. So let's say we edit the current configuration. Well, this is using a dynamic address. Well, it is a desktop. We're treating it as a desktop, so that's fine. So we need not give it a static address or any additional addresses, aliases. That's where you would put it. So that means for the other systems, that's where we would make those changes. Anything else, MTUs, etc., whether or not the device should be activated when the system boots, or if hot plugged, or when the cable is connected, when it detects activity on the wire, etc. So this area gives us those settings. Host name, of course, well, this is using a generic name, so let's just say we call this Linux CBT SLES12 Desk1 or something along those lines, anything generic. And our domain name is, of course, linuxcbt.internal, so we'll give it that. And now this changes the host name via DHCP. We don't want to do that. DHCP will serve the DNS information. Routing is also picked up, but you can include other networks. We have other networks behind various PF instances. And we'll just click on OK. Just to make those changes, we'll look at some other changes or network-related changes momentarily as we install the other nodes. We just want to get the host name going, make sure this is recognized so that when the clients connect, the names are properly presented. And when we connect to other servers, it's presented as user at host, host being the name we just specified, Linux CBT SLES12 Desk1. So that gives us those settings. Now, if you're interested in other settings, they're here, etc sysconfig, the different objects, etc. For now, we'll just ignore those. Let's just say task, one update, host name via YAST. Now, the thing with SUSE is we end up doing so much of the configuration via YAST. It's a very capable tool. So although the config files are there, you can pretty much manage the majority of your system, which makes it truly an enterprise-ready distro of Linux, because so much of the system can be managed via YAST. Now notice that this shell, the existing shell, still reflects, or the existing shells still reflect the host names. Shells read their data upon invocation. So these shells, these two shells were launched before the system name had been updated. So 0 and PTS1, but PTS2 presumably read after the changes, and that's why it's updated accordingly. In older versions of Linux, you had to log off and re-log on to GNOME in order to witness these changes. But nowadays, things are being updated more dynamically, so the simple invocation of a new shell reflects the new settings, and that makes things a bit smoother. Hostname full. Let's see if we've got our hostname command. And the full option is not an option with this particular release, but there's our hostname. Actually, it should have shown it. Hostname F, so it's not reading it, but that's fine. But the short name shows, and that looks good. Let's check our IP settings. And there's a DHCP, 7525. Default gateway is 75.1. Let's look something up on the net, make sure we can get out. And let's cat etc resolve 75.1, so it's a DNS server. Let's dig somewhere else. Let's say we dig at 75.101, and it's not coming up, so that could be firewall related. So we'll look into that once we get up and running. So we have our desktop up. There's a few tweaks needed. And let's move on. We're going to install the server several times, or a few times at a minimum. Get some instances going, and it will start relating between SUSE Desktop and the server.